Hey guys, welcome to your go-to guide for fixing your home AC system before calling in a technician. As we know, HVAC repairs can cost hundreds, but the truth is, many problems are easy to solve on your own. In the next 30 minutes or so, I'll walk you through 5 key checks that could get your AC back to cooling, all without special tools or advanced skills. So here's what we're going to be covering: how to change your air filter, how to check your capacitor, how to clean your outdoor coils, how to replace the fan motor, and how to check if the compressor has failed. Each section is beginner friendly, safe, and something you can do right from your own home. So let's get started. So we're going to get started with the easiest and the most overlooked. That's the air filter. It's the first defense against poor airflow, dirty coils, and an overworked system. So you're going to want to locate the air vent. It has a slot. It'll be white. It could be down the wall or up in the roof. If the filter is gray, dusty, replace it. Make sure you use the same size and that the airflow arrow is pointing towards the system, so into. Filters should be replaced every 30 to 90 days, depending on usage. And a clean filter is less stress on the system. Another thing is, during the summer, I like to go to Walmart and use the green pig hair, because if you have a system that struggles with the paper ones with airflow, that's something that I like to do. Let's get into it. Let's check it out.
Here with the Handyman Journey, and today we're going to walk step by step on replacing the air filter in your house. First things first is you want to locate your return air duct. Typically they're in your ceiling. Sometimes they're on the wall up high. Sometimes they're on the wall down low. One thing you want to note, if you do have a return air duct that's on the wall down low and you have a lot of animals like dogs and cats, you want to make sure that thing doesn't get clogged with dog hair or cat hair and things like that. So once you've located your return air duct, you're going to want to set up a ladder if it is on your ceiling. Make sure that you're nice and safe. And then there's 2 clips, one on either side, that you're going to want to go ahead and release. And it will come down, it will hinge on this side. So once you know that, you'll release these 2 clips, you'll let it hang on one side, and your air filter will come on out. And then on every air filter, there is the size that you need to locate. And once you've located the size, you take that size to the local hardware store, get yourself a new filter, and go ahead and put it in here and replace it. And one other thing to note about air filters is they are directional. So the way that this works is the air conditioner sucks in air this way, runs it through the filter and out throughout the vents in the house. So you want to make sure it is directed correctly where the airflow is going up. Go ahead and hold it up in there, close your vent door, and reclasp your latches.
All right, so we are going to be using other people's content because I figured I didn't want to show you guys
you are good to go.
Terrible content, like, you know, my audio and my video is just terrible.
A million things going on. I have been trying to fix. Everything just keeps breaking around here.
So I figured then, rather than having y'all sit through that terrible video quality, I would show you guys some videos that I found helpful. And so make sure you go check out these videos. I'm going to link them, and also to make sure to like and to follow them as well, probably for more tips. All right, so the next step is going to be checking your capacitor. I'm going to show you how you can do this with the proper meter and also with a regular multimeter that just has the ohms mode, which you can see here on the screen. So not going to take too much time with this. It's the most common failure point, so you're going to want to check this. For safety first, turn off the system at the thermostat, shut power off at the breaker box, pull and disconnect the outdoor unit switch. It's a little black switch, so if you go outside by your AC unit, there's a little box. You'll see the wire going to it. You just lift the latch open, pull that out. But before you do that, you want to make sure you turn your system off. So you don't want to have the fans running. You don't want to have the system set to on. You want to make sure it's set to off, and that's done at the thermostat level. And you're going to want to have a multimeter for this. You're going to need to discharge the battery before you take it out.
We're likely going to see something like this, a capacitor with a bunch of wires going to it, and that's the fella that we need to discharge. Now, as far as safety goes, the most important thing is to turn the power off, and then make sure the power is off, and then verify that the power is off, preferably with a multimeter or a voltage pen. If you forget to do so and try to discharge the capacitor while the power is on, whatever tool you're using is likely going to get welded onto the capacitor. How do I know this? Well, unfortunately, I tried that as well. So do make sure that the power is off. The way I discharge a capacitor is simply by using a screwdriver. And let me pause here because I know some technicians will right away say, whoa, 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 Jay, that is not the technically correct way how to discharge a capacitor. And they would be right. The right way would be to use a pair of jumper leads and a resistor to discharge it. But personally, I have never actually used that method. I've always used either a screwdriver, a nut driver, or some needle nose pliers. The only thing you have to make sure is that the handle is plastic or rubber, so fully insulated.
Now, I do want to say on this, you want to make sure you use something insulated, because I've used a plastic screwdriver, and I guess because the handle was deep enough or whatever, it still shocked me. I don't believe it was a capacitor. So I just used a piece of painter's tape and a small screwdriver just to touch these terminals across. That's how I've always used it. He is correct. The other way would be best, but you can do it
from the shaft.
We're trying to do trying to do it as cheap as possible. So this, I'm going to show you how you can do it also with like a multimeter from Harbor Freight, a $7 to $15 multimeter.
And all the technicians that I know, none of us use the technically correct way. I think it's an unnecessary step that's really not needed. And if you disagree with me, I won't be upset. If you desire to use this method instead, that's totally fine. There's some videos on how to do it this way as well. Or also on Amazon, I saw a capacitor discharge pen. That's pretty cool too, and it's a little bit less annoying than using the jumper leads. If you would like, check it out. I'll leave an Amazon link in the video description. Anyway, let's get back to showing you how most HVAC technicians do this. So to discharge a capacitor, all you gotta do...
For nearly 50 years, Harbor Freight has been a reliable source.
First,
sorry about that.
These dual capacitors, they should be labeled. You got C for common, you got HERM for compressor, and you have fan for the condenser fan. All you need to do to discharge the capacitor is to take a screwdriver, a nut driver, or maybe a needle nose pliers, and short out the terminals between each other. You might see a little bit of a spark when you do this. And some people ask, how long does it take to discharge the capacitor when you do this? And the answer is, it's immediate. It discharges right away. The reason I rub it like this is just to make sure that I got a good connection between the two spades. And another question I get is, does it matter which spade I touch? See how there's 4 of them here? And the answer is no, it does not matter because all these spades are connected. If you look in the middle here, all of this is basically one piece of metal. So I can go from this side, from the top, or from this side. It does not matter. So you discharge the fan side, then you would discharge the HERM side the same way. If you accidentally go from HERM to fan, most likely nothing will happen, although there is a chance that you could damage the capacitor. Which brings me to another question. Some people ask, does the capacitor get damaged when you discharge it like this? And usually, no, it does not get damaged, but there is a slight chance that it could get damaged. The likelihood of that happening is very, very slim. I've checked many capacitors that were good after I checked them, so I don't think this happens very frequently, and the only way I think it would happen is if you discharge.
So that's good to know on how to discharge it first. It'll probably still be on the unit once you have disconnected the pull out.
And this is the Mastec 8268, but there's many multimeters that can do this. Now, the first thing you want to do before you measure the capacitance of a capacitor, you need to
And this is going to be how to do it with a continuity.
What you need to do
Multimeter.
is you take a screwdriver or something metal or a piece of wire.
Okay, so he's showing something we already
You definitely
saw.
want them discharged before you start measuring the capacitance. All right, so let's start with this air conditioner dual run capacitor. So we'll turn this to the capacitance setting right there. And on this one, it's a 45 by 5 microfarad plus or minus 6%.
Okay, so as far as the capacitors, your numbers might be different. You want to make sure you match the voltage as well. So my fan's like a 330, but I have a 440. That's because you can run a 440 capacitor since it's more in the voltage and it's safer. but you can't run less, meaning I couldn't run if there was a 200 voltage. I could run at 330 as my bare minimum, but it wouldn't last as long as far as the capacitor. But you have to make sure you match the microfarads exactly, and that's going to be on your fan, and it's also going to be on the condenser, or I mean on the compressor. There's little labels, and it'll tell you. It'll have like a little micro symbol and then a capital F, or it might say MFD.
So we need to find the common. Here's the C, so this is the common, this is the fan, and this says HERM, stands for hermetic compressor.
Yeah, so the HERM is the compressor. That's another thing I wanted to go over, and I'm glad he went over this in the video.
So to measure this, or to test this, you're going to measure from the common to the fan and from the common to the HERM. And the HERM is going to be the higher value, so that's going to be, or should be 45, and from the common to the fan should read close to 5 microfarads. So let's give it a try. All right, here's the common, here's the fan. Okay, you'll see it build up. Okay, so it's reading 4.856. That's within 6% of 5. So this one's good. All right, now.
All right, so we don't need to watch how to do it on the other one. If it's 45, then you're going to want to be within spec of that. So, you know, I guess 4 to 7 to 5 to 3. So if it's 45, then it's going to be, you know, 44.7 to, what is that? 45.3. So how to do it with a regular multimeter the way that I did it.
40 volt capacitor.
And that's the same.
Actually, it is
Harbor
possible
Freight
to test to
multimeter.
see if the capacitor is actually working with a $7 meter. This is a cheap meter I bought from Amazon. I'll put a link to it in the video description below. And I'm going to be using it to test this run dual into the actual meter. And it's enough. They're high voltage devices. And before you even, please understand that how to discharge these and that they need to be discharged. So I've already discharged these 2 capacitors, so we can go on from here and start testing them to see.
And he did it the correct way.
Valid
resistor.
or good capacitors.
Love games but hate the grind?
However, and again, I'm aiming my videos at the novice, so please bear with me if you already know this. Basically, I'm showing you where to put the leads into the actual meter itself, and you can see that the black lead, and these just slide in there, pop into that into those holes. The black lead goes into the common hole, okay? And you see, it should say COM, and you should see a symbol of like a ground on there. And so let's put that in there. The positive lead, or the red lead, goes into the voltage, ohm, and milliamp hole. Now there's a third hole here that says 10 DC. That means 10 amps DC. Okay, so, and what we're going to do, you don't have 200K, go as high as you can, and hopefully that'll get 200K ohm at all. We're going to deal with voltage, ohms, and milliamps. So we're going to put that in here. Once you've got that properly set, the next thing you're going to do is turn your meter on and set the gauge to at least the 200K ohm setting. Okay, you can go lower, and if you don't have 200K, go as high as you can, and hopefully that'll get the result you need from the meter. So let's take it and start testing the capacitor. All right, I want to stress here that this capacitor has been fully discharged, and what we're going to do here is check to see if the capacitor actually can take a charge. And basically what we're doing is we're going to use the resistance mode at 200K on 200 kilo ohms on this meter, this cheap little meter, to put 5 volts into this, which is what it's going to do. And then if it does exactly what it's supposed to do, which is start with a low resistance, move all the way up into an open circuit, we know that the actual capacitor is working. So let's do that. Negative on the negative, or the common, and then we'll go over here onto the positive lead. And you can see it's taking a charge, and then boom. When it hits 200, it says, okay, open circuit. There's no more left to...
Mine says OL, I believe.
no more resistance to check. It's an open circuit now at this point because the 0.5 volts that are coming out of these leads can't be, won't accept anymore. So as far as the meter is concerned, it's an open circuit. So here, if we want to test it the other way, we just reverse it. You can see it going down in the negative. So we're discharging it now, and now we're charging it back up again. We just changed polarity. And again, it's going all the way to 200, and then boom. Okay? So we know this capacitor is good. It's taking a charge. It's doing what it's supposed to do. Okay? Now we're going to do the same thing over here to the other capacitor, which is the fan capacitor, in reverse. There's no damage on this. It's only 0.5 volts.
He did the same thing on the other side. I didn't want to, keep going through this. Make sure to check both sides, as he said. Like both ways.
And there you can see how that goes all the way to 2,000 kilo ohms and then says, okay, that's it. So we know this capacitor is good because it's performing, it's taking a charge and doing exactly what it's supposed to do, storing it. Okay, so if you see your capacitor performing that way, this is a good capacitor. Okay, I will test it with a regular multimeter in a minute so you can see what the actual values are here. And again, this test only tells you that the capacitor is working. It doesn't tell you what kind of capacity it has. It just says, hey, it's taking a charge and storing it, what it's supposed to do. It's a capacitor, right? So good capacitor, no problem there. Let's go with one that I know is blown. Okay, this one here. And if you want to know if a capacitor is blown, first thing to look for is damage. This one has
puffed up.
The top of it is all bulged out. It's bubbled up. I don't know if you can see that at that angle or not, but it basically has a big bubble. You can see the dent here. If you see a leak on them, or if you see a crack in them, or if the bottom is bowed out, or any part of the capacitor has something that looks like out of place or basically wrong, then don't even bother. Just replace the capacitor. This one here looks like a soda can that's been left out in the sun, basically. It's done. This is definitely a bad capacitor, but we'll run the same test on it and we'll see what we get. So common, go here on the common, go to Herm first, and we'll take it down to 200K there. Nothing. Dead.
So if it shows no value, like open circuit, or that it's OL like mine, it's not taking any charge like the last one. So that's how you can tell there. That's how you check your capacitors. Make sure the three labels to know are common, which is C, your fan, and Herm. So the common's basically the ground, so you connect the fan to the common, the Herm to the common, and then you reverse those polarities. And that's pretty much it for that. All right, for step 3, we're going to clean the outdoor coils. So we're going to check that out now and see someone who got a lot of great feedback that he is
your
really
AC
extensive.
is just...
Now, one thing I want to say is if you have aluminum finned coil, exterior coils, you do not want to use high pressure on them. So like even the jet on your hose would be too much. I just use full and shower and a cone mist.
not running as cold as it used to. This could be caused by clogged or dirty AC coils. In fact, when they're clogged and dirty like this, your machine doesn't run as efficient and it ends up costing you more money when, well, you're running your AC in the hot summer months. So let me show you the best way to clean that up. The first place to always start before we do any cleaning is to turn the power off to the machine. And many times there'll be a breaker box right next to your AC unit.
And that's the box that I told you about with the pull-out switch.
Just open up the hatch here. Now you'll notice there is a breaker right here with a little handle. Right now, because we can read it in the on position, there is power going to the machine. So all you need to do is just pull this out. It can be a little bit stuck sometimes. Just kind of carefully grab it there. Okay, now we got it out. There is no longer power going to the machine. Now you'll notice on the breaker here, when you can read on, that's on.
But remember, capacitors hold a storage charge.
On. You can also flip it upside down. We can read off here. So you can put it back in that position if you'd like to.
I don't
It'll
do
snug
that.
right in there. What I like to do is just set it on top. That way
That's what I
don't
do.
forget to put it back in and turn it on once everything's nice and clean. Another quick thing to keep in mind is always make sure you close your breaker box door here. We do not want water to get in there during the cleaning process. Now, this home has a very close breaker box to the machine itself. And sometimes when you set this on top like I'd like to, you might be a little bit in the splash zone, so you want to keep that in mind as well. If you think it's going to get wet, in your garage. That way, once it's done, it's ready to go back in. The next step is to remove the top on the unit itself here. Now, everyone's is going to be a little bit different in the configuration and how to do this. If you're not quite sure, just give it a quick Google search with your make and model. But mine here, I know there's about 8 or 9 screws around the top. So we're just gonna remove those so we can easily access the inside. Something to keep in mind while you're removing the top here is there are still going to be wires and things attached to this. So we want to be very, very careful, can be a little heavy too, that we don't pinch those in any way because we don't want to cause damage to them. The other thing to keep in mind as well is we don't want to damage the fan blades. If you bend these, get them off balance, your machine is going to start making noise after the cleaning. It could just cause other issues with it not being as efficient, and we don't want that. Sometimes if you can't get quite the right angle for the top to stay here, sometimes you can kind of balance it like this. Let's see if I can get it to stay. If you can't get this to happen, you might need to grab a cleaning partner or just hold it yourself.
Now, if you don't have a way that you can lift it up and have it set there, you're going to want to disconnect the fan. I'll show you what I did. What I did is I looked at my fan and I saw the wires that I had. There was 5 total. And I took a picture of what I disconnected. So this blue one I took disconnected from underneath this brown, this yellow common from below this yellow, this black ground which had another ground on it. I had to undo this wire nut, take the yellow and green, put the wire nut back on, and the brown from next to this, I think it's a black ground that went to the compressor. So once I did that, I was able to just set my top off to the side
while you do the clean, because you don't want to cause any damage to this, so be extra careful. Before I start spraying any cleaners on the machine here, what I like to do is just grab a quick shop vac and just suck out all the debris from the inside.
Yes, I did that with mine. Just take a look here how much I actually had in my unit.
You want to be careful.
So a lot of that you don't want to start spraying because there's holes, the leaves won't get through, the dirt will be stuck in there. It's just so much harder.
Many times, depending on where your machine is located, things like leaves and bark and all sorts of stuff will work its way inside. And it's a good idea to remove this. That way it's not going to clog up the machine or cause any issues while it's running. Something I might mention throughout this clean a few times, so bear with me, but I just want you to be as safe as possible, is the fins along the coils here are extremely delicate. Just the smallest amount of pressure can cause them to bend or warp, and we don't want that because it could cause damage. So look out for that while you're vacuuming the inside. So now that we got most of the debris out of the inside, if you actually come take a look here, you'll notice down here these little ports. These are drain holes for water to go out of. Now, you'll notice like this one kind of has a bunch of mud and junk in there. Don't worry too much about this. We'll get this all sprayed out really well. But after you're done cleaning, you just want to double check these and make sure that they're open so that the water can easily get out of there so you don't have that building up. Now, as I was kind of removing all that easy dry soil on the top, I just kind of threw it on the ground, not thinking. But something to keep in mind is that any dust or debris that you throw around this machine, it's going to suck into there and kind of just make it dirty again. So
just throw it in your shop vac.
Like what I did, pick it up and throw it away. So now that we got all the dry debris out of the inside, it's time to finally clean the coils. Now, what I like to use is this one here from Frost King. It's just a foaming cleaner. It does a really good job and the one that's worked the best for me in the past. Now, I will say there's a ton of them on the market, and most times you can find one at a big box store. This one you can find at a lot of those, and even on
I used Simple Green from Home Depot, and it took like 3 times to get fully clean. I'm sure that this guy's works way better.
My Amazon storefront. I'll have that link down in the description below. Now, it's pretty easy to use. Just pop the top off and start spraying everything down on the outside. Usually I like to start at the bottom because that's where it's very dirty, and just work my way up to the top here, paying special attention to kind of those problem areas where there's a lot of buildup. Now the nice thing about a foam cleaner like this is that it builds up on the surface and kind of sticks to the actual fins and the coils there, and then it just gives it time to work and break down all of the buildup on the coils there. Some cleaners, they don't foam up as well, and they don't work as well just because they can't stick to that surface and do their job. I really like about using an actual cleaner for this that's designed for the job is it has a good straight spray nozzle. That way it can penetrate into those fins and get in all those cracks and crevices, opposed to if you're just using more of a fan spray or just a spray bottle, sometimes it's hard to really penetrate those areas. Now, if you've watched the channel before, you probably already know what I'm gonna say, but dwell time and letting your cleaner work is everything, especially with this job, just because there is a lot of debris and a lot of small little areas there and grooves that it can get into. Actually, if you come real close, you can already see it starting to break down that layer there that was on the top. So it's working. We're gonna let this sit there for anywhere from 10 to 15 minutes. Just set a timer on your watch or phone and let the cleaner do the job. You'll notice here this is a single walled unit. Sometimes you might lift the lid and notice 2 walls of coils there, and that's very normal, just depends on the type that you have for your home. But I will say, you notice we sprayed the cleaner on the outside, but when you have that dual wall there, it's not gonna be able to penetrate to the second one. So sometimes it might be a good idea to spray the inside of that second wall, just the problem areas, to make sure to get it as clean as possible. So my timer just went off, and that means it's time to give
I did both sides.
everything a
And I have a single wall.
real good rinse. Now there are a few things to keep in mind while you're doing this. First, you want to be as gentle as possible. We don't want to use any sort of high pressure or pressure washers here because again, that will cause damage to the fins and bend them, and then your machine is just not going to work as well. Now I will say I like to use just a garden hose with either the fan or shower setting, just something really gentle, not a ton of pressure. The goal here is to more get rid of the soap and the debris, not to just blast it out. I also like to start on the inside and spray towards the outside, because a lot of times with these machines, they suck in air, so most of the debris is on the outside of the machine. So when we spray from inside out, that means we're pushing it out and not pushing it further in, so it's completely removed. Now this whole process might take a little bit, but again, just go slow. There's no race here. You wanna just make sure to rinse it as good as possible, but again, not cause that damage to the fins. Now I will say this cleaner does say it's no rinse, so if you do leave a little bit behind, it's not the end of the world. I just prefer to rinse everything out the best as I can. That way I'm not gonna leave anything potentially sticky behind that could attract more dirt and just make the whole clean harder next time. Now quick pro tip, while you're rinsing everything, maybe wear some like waterproof shoes, because I wore these Vans and I love them, but now my feet are soaking wet. Once you're done rinsing and everything is nice and clean, it's time to put the cover back on. Again, just be mindful of those wires. We don't want them pinching or anything, so make sure they're nice and loose.
And that's why I took pictures, because I wanted to make it as dummy proof as possible. All you have to do is run those wires back through, wire them up, and then probably just electrical tape all the slack back up, because you more than likely had it already tied up. At least mine was, if you had some sort of professional installation, because you don't want a bunch of loose wires.
And then once you get one screw hole kind of lined up, usually all the...
And also, as I talked about, these are either 8 or 6 millimeters. Most of my tools around the house, like any other appliances, whenever it comes to the chassis, it's going to be this 6 millimeter. But I do have newer units that I don't know if it's my Kenmore or what I have. But there's been one that has an 8 millimeter. So I recommend just getting these little hex drivers that go into your bit driver. That way you can just get the different sizes.
The other ones fall in line. I will say this job usually takes me anywhere from 35 to 45 minutes to do. It just depends on how dirty the machine is. And I do recommend, if you can, to do this at least once a year. That way your machine is going to be running as efficiently as possible. And this kind of depends too on your environment. If you're in an area where the machine is running 24/7 and you have a lot of dust in.
If you have a system like mine, I had where you have to take them all around off the top and then take the fan off, and then you'll have panels. So sometimes you'll have screws on the side so that you can lift the panel straight up, and then they go back into place and they have legs. I'll have to find a video and show you that. So this is my unit. As you can see, there's I guess I didn't need to take these out, but it didn't hurt taking them off. There's just side panels, but you have these legs. So you're gonna first take off the screws all around the top, take the top off, and then you're gonna lift up straight up on these panels and they'll come out. For these, the ones on the corner, the 3, if you just pull them towards you, they'll go down towards the ground, and then you can lift them straight up, and that's how you can take those out as well. So I wanted to make sure to cover that.
Now, something to keep in mind with this job is this machine does just sit outside, so it's not going to come out perfectly clean every single time. There's going to be some just wear and tear just from it being in the elements.
Yeah, so that's that, and it doesn't always come out 100% clean. Here's another reason I didn't use my content, my voice. I was feeling sick, but here's my cleaned unit right here.
All right, so we have cleaned.
We saw the one before was
all the way around
in the last
the unit.
picture.
We have cleaned the inside.
And if yours is like mine, make sure to pull out any weeds to get any elevated dirt away. So I actually dug a hole and I just blasted all the dirt towards it. And then cleaned it so that way I don't have to worry about the dirt going back into it. You want to be mindful of that. Next up, if your fan isn't spinning or it squeals, buzzes, spins slowly, like mine, I noticed it was spinning backwards for the first click and then spinning forward on the capacitor. That was bad. So that was the capacitor, but you might have a motor replacement if you're having that sort of issue. So you want to power off the system as well. Disconnect the wiring as I showed you using something to take a picture to go back. Unbolt the motor from the housing. So you'll see how to do that. You want to make sure you match the replacement motor based on the horsepower, the RPM, the shaft size, and the rotation direction. It's going to be clockwise or counterclockwise. Many motors are reversible. There's going to be a black and white wire, and you can just flip that around and it'll tell you which way is which. You want to install the correct capacitor because you can, upgrade your fan capacity, upgrade, the RPMs, but you want to make sure your unit is rated for it if you're trying to get more airflow. So you want to make sure the correct capacitor by matching the microfarad. The micro looks like a backwards U or MFD. You can upgrade, like I said, the 330 volt fan to a 440 volt capacitor. Just make sure you match the capacitor to the farads. So for instance, these two are on my systems. This is the one that I replaced. This is a dual run and this is a single phase. The dual run will have one, the 45 going to the compressor, and then the +6 is going to the fan. Now the most common is going to be the ±5, the ±7.5, and some even have a 10. So you want to make sure that matches, as well as checking your voltage. So this is a 440. My fan is a 330. So this means my capacitor is going to last a little bit longer. And as we learned, the capacitors might look different, but they'll be labeled so you know which one's control, which one's fan, which one's the compressor, which is the HRM. And some might have one just for the compressor and one for the fan. I'm assuming I can do a dual run setup here if I matched the 7.5 on my capacitor if I had a dual run. But I'm not going to do that. I have the replacements here for this. I have the replacement capacitor and the replacement single. So now we're going to get into replacing the fan.
Remember my last home zone, I showed you how to change out the capacitor when the old AC stopped working, people hoping to be cold as ice. This $15 part right here looked kind of like that. Took me about 15 minutes to change. It also saved me about $300. In this week's home zone, how about saving double that by changing out your fan motor?
Sometimes they don't spin well, even get locked up. My AC tech said the larger unit of mine tested bad. He also said it would be $800 to fix it, $500 labor, $300 parts. So let's see if I can do it myself with no specialized tools. Let's go. First, for a DIYer, get a direct factory replacement. That way you have the same motor and wiring.
Now it's time to disconnect the power from the AC unit. You can do that right out here by the AC disconnect, or you can also
flip the breaker inside. I'm doing both. Captain Safety. And just like when I replaced the capacitor a few weeks ago, it's time to take off the side panel. It's just a few hex screws. Now, take a few pictures because you'll be pulling off the wires that go to the motor. Now it's time to unscrew the entire fan assembly. Mine are held in by these little screws that go all the way around the perimeter. Some are just around here. Whatever you do, you don't want to remove the top 4 that hold the fan and the motor because it'll fall down and go boom. Now,
on top of the compressor,
go to the motor. There was a tie holding all those wires together, so I snipped it off. Once free, I pushed the 3 motor wires back through the hole so the assembly can be lifted out.
You can use electrical tape to put them back together, by the way.
Be free! Now it's time to loosen the one lockdown bolt that holds the shaft to the fan, or vice versa. This could be rather rusty, so you may need to use some loosening liquid. But either way, wear gloves so you don't cut yourself. That worked. That's pretty easy. Also take note where the fan is tightened down onto the shaft, flush in my case. To remove the fan, I just grabbed the motor shaft with channel locks and wiggled the fan to pull it off. Be sure to note which side of the fan is facing up or down. If you put it back on the opposite way, it won't blow the air up and out, and that can do damage. Let's see, lefty-loosey, righty-tighty. Here I'm unscrewing those center nuts to remove the motor and the fan from the top piece, but you may want to hold it on better than I did. Hey, it fell down. Now that it's on the lawn, let's double check the new motor and shaft to match up with the old one. That looks good to me. I also kept the sleeve that contains the wires to reuse it. Now put the motor back onto the assembly piece until the 4 bolts fit into the holes. Then put the nuts back on from the opposite side to hold it all together. Time to slide 1 wire at a time back through the sleeve. If you try to do all 3 at a time, there's no way they're gonna fit. And once the wires are through, slide the sleeve back on. Time to put the fan onto the new motor shaft. Same direction. Make sure it's flush, not way down there. Same as the other one. Hope that holds. Now I put the assembly back on top of the AC unit. Now we need to put these wires to the hole before we totally put it on, you know what I'm saying? Those 3 wires go through the grommet hole where the capacitor is and get reattached to the proper terminals. Refer to your picture if needed. Once done, put on a brand new zip tie. Now align the entire fan assembly where it was on top, making sure one side doesn't pop out. Finally, screw it in and reattach that side panel. After screwing on the panel, I like to do it with my hands versus a drill. I like to feel the tension. And the tension rises as it's time to put the disconnect back in and flip on the breaker. It worked for $200 in parts and done in under an hour.
Yeah, so again, you're going to want to check if it's not spinning, squeals, buzzes, or struggles to start up, makes a bunch of noise before it finally starts fully going. After you've changed the capacitor or verified that the capacitor is good, you might want to change out the motor. Make sure you match the fan blades to the horsepower of the motor. You might need to use ChatGPT to ask if you can cross-reference any of this stuff or what your unit's capable of. Alright, now for the heart of the AC system, the compressor. If your fan runs but there's no cold air and the unit clicks or hums, it may be a compressor issue. You want to turn off the power completely again. Remove the access panel, locate the compressor terminals. You should see 3, the common, the run, and the start. Use a multimeter on resistance mode, and you're going to put the common to the start, the common to the run, and the run to the start. So it's going to show you in this video how to do that with a regular multimeter. You're going to do this when it's outside out the unit because you can't remove the compressor if you don't have a way to capture the gases inside. And in order to do that, you have to be licensed and EPA certified in HVAC repair or work for someone, I believe. You don't want to bleed any of this out to the atmosphere. So one way to tell if it's not running just audibly is it sounds like an air compressor almost. You'll hear it humming and rattling after you replace that capacitor. You'll hear the fan. Usually that starts first. But you'll hear it click twice from the capacitor. So you'll hear that refrigerator running / air compressor sound.
a hermetic compressor. I'm going to show you guys today how to use a multimeter to troubleshoot compressor issues. All right, so what you guys see here is your typical Y arrangement that represents windings in motors that you would see on schematics. Now what I want you to do here is take note of the actual physical structure here. So when you have start and run windings here, and you can see how they meet at a common point right here in the middle. So physically, if I did a continuity reading between run and common, I will always have a closed circuit between those two because there's no switches, there's nothing. I will not get any readings between. I'm reading much larger number of ohms. We're reading single which with your multimeter, and the event you don't have anything that tells you otherwise. So what we're going to do is we're going to take our probes, we're going to put our multimeter in the ohm setting, not kilo ohms or mega ohms, just regular ohms. We're reading single double-digit numbers here, nothing crazy. And what we're going to do is we're going to start randomly testing any two pins in different combinations. So if I go from this pin to this top.
As we said, take note. There should be a common run and a start, a C, an R, and an S. If yours is labeled, you can do random, but you're going to want to do the common to start, common to run, and run to start.
Pin here, you can see I'm reading about just under 12 ohms. If I go from that top pin to this pin over here, I'm reading about 5.5. And if I go to these two pins here together, I'm reading much larger number, almost 17 ohms. Once you identify the largest number that the two pins give you, that is your start and your run winding combined. So the third one is going to be your common. So these two bottom pins here give me 17. That's my largest reading. That top pin there is my common terminal. Now you notice if I go from this pin to my common, I'm reading just under 12. And if I go from this pin to common, I'm reading about 6. So I should read about 17 between these other two pins here. And there you have it. So your run and common, start and common will equal start to run. So we know this top.
And to tell if yours has failed, it's going to be 0. I don't know if he's going to show us that.
Pin here, that is our common, but how we know which one is run and start? The run winding is always going to give you the lower value of the two. So if I test this pin to common, see I'm reading about 5.5.
That's really all you need to know. And that's in about 42 minutes that we've covered this, because I don't think he's going to show us
ohms there.
The OL open circuit.
Go from this pin to common, I have a larger reading, almost 12 ohms there. So that smaller one is going to be my run winding. And I'm going to ground it to the lower value of the two. So if I test this as my common, that is my run, and that leaves this one as my start winding. Now, a really stupid, easy way to remember that relationship is just the number.
Now, if your compressor is giving you issues, I'm going to link all these videos and in the description so that you can watch them extensively, and you can go like, follow, subscribe, whatever it is. But that should be just about everything that you need. So I thought that these were great, informative videos to put all in one place, for something for you to check in less than an hour's time on your own system to help save money, make sure your system's running properly, maybe even fix your own. So again, we'll recap. First, change the air filter. Second, test, replace capacitor. Third, clean the outdoor condenser units. Replace the fan motor number 4, and then diagnose a compressor failure for number 5. So these common 5 checks cover over 80% of common cooling issues. So you now have the knowledge and confidence to go check this yourself and to save some money. So if you found this video helpful, give it a like, subscribe to my channel, drop a comment below what you'd like to see next, and make sure to go follow out these awesome content creators that created these great videos as well. So my name's DudeJayStarr. Stay cool, save money, and I'll see you in the next one.